Okay, let's go ahead and get started. So welcome to the Tech Academy's Introduction to JavaScript class. I am your host and instructor for the night. I'm Erik Gross. I've been programming computers since I was 11, but professionally, I've got about 35 years or so of experience. And I'm also a Navy vet. I was a nuclear reactor operator and electronics technician in the Navy. A long time ago. In fact, I got out over 30 years ago, which tells you how old I am roughly. And I'm also the co-founder of the Tech Academy, the software developer bootcamp and training organization that puts on these free classes. Here's basic guidelines on the class. We have an assistant in the chat, Gracie. You'll see her from time to time, right? She's there to monitor the chat, answer questions, make sure everybody's asking, being really nice. One of the big things about these classes is that while they are intro to coding classes, they can be challenging, right? And that's part of the learning process. So just use chat as needed. And I try to watch chat all the way through the coding portion. And speaking of the coding portion, one of the biggest pieces of advice I can give you is to make sure that you type the code that we're going to write exactly as it's written. And this is because a misspelled word or missing symbol or even something that's capitalized when it shouldn't be capitalized can all result in errors in your code. And so just try to watch exactly what I'm typing to make sure your code looks exactly like mine. One of the other big things that's important is make sure you're in a distraction-free environment so you can focus on the class, because I don't want to lose you on anything. With that said, if you get lost or you can't keep up with the coding, please stick around. Don't go anywhere. You can still learn a lot, even if you fall behind on the actual typing of the code. The video of this class will go up on our free YouTube channel, either later today or tomorrow, and we'll give you links to all that. You'll also get the full code for the game that we're going to look at the end of the class. You'll be able to play the game and mess around with the code and tweak it to your heart's content. All right, now we've had a few new people arrive, so if you haven't already let me know where you're joining us from, drop into chat and let me know where you're at. I'm in Louisiana. Slidell, Louisiana, actually. We've got people from all over the country so far. Boston, San Francisco, Vancouver, Canada, Detroit, Michigan, Southern Utah. Oh, Seattle, Washington. Awesome. All right. I heard you guys had a weather event up there a few days ago. Oh, yep. In San Francisco, the weather is horrible right now. I'm sorry to hear that. Yeah, we are flying into San Francisco next Tuesday. Excuse me. Wow, hold on. Yeah, we're flying into San Francisco next Tuesday to go visit my family up in Northern California, and I'm not looking forward to the weather. Awesome. Robert. Oh, Robert. Hi, Robert. Robert's joining us from New York. All right, let's go and get going. Apparently, I need to sneeze roughly 87 times before we start the class today. All right, so basic agenda for the day. We'll have a short explanation of the Tech Academy, who and what we are. We'll write code. Get your hands dirty, writing actual computer programming code. We'll have a brief Q&A session, go over some information about who we are and our boot camps. And we've got a free gift for you at the end, so please stick around. Whole class should take about an hour, hour and a half. I'm just curious on something. Do me a favor, drop in the chat and give me a yes or no to the question. Have you written more than 2 or 3 computer programs in your life? Yes or no? Have you written more than 2 or 3 computer programs in your life? No, yes, yes, no, yes. No, brand new. Excellent. Okay. About 40-60. 40% no, 60% yes is what I'm seeing right now. That's excellent. Okay. For those of you who are already experienced coders or have at least a little bit of experience on your belt, one of the things I want to stress before we go any farther is that At first glance, some of the material I'm going to go over tonight may seem super basic and rudimentary. In my experience, there's still tremendous value in it for people that already have some experience programming. And I'll go over why when we cover each of those fundamental points. But I'm just going to encourage you to look for things that you can learn tonight that will reinforce fundamentals for you or give you a valuable way to tell people who are not technology trained how the fundamentals work. It's a really valuable skill as a technologist, is to be able to impart complex technology concepts to non-technology people in a way that isn't like condescending and is super effective. And so hopefully you'll get some of that out of tonight's training as well. All right. So basic information about the Tech Academy, who and what we are. We deliver boot camps. Boot camps are intensive training programs that prepare you for entry-level positions in the technology industry. Typically, boot camps last between 3 and 6 months. They focus on practical modern skills. At the Tech Academy, we've been offering really thorough, budget-friendly, flexible, trusted coding boot camps for over a decade. In fact, we're coming up on 11 years now. These programs that we deliver are cost-effective. They are self-paced. They're fully online. They're tailored for beginners, people that have no prior technical or coding knowledge, which is pretty cool. Okay. We cover in-demand, skills for the tech industry. Our programs are endorsed by stellar reviews online, and they're designed to be really flexible, fit around your schedule. And we want to prepare you for a technology career with a really well-rounded toolkit. In terms of price, the national average in America for boot camps is around $13,500, right? We're priced well under the national average, and we have boot camps that start as low as $59.80. And I just want to wrap this part up with our mission statement. The mission statement of the Tech Academy is to graduate entry-level professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. All right, now let's get started. I want to cover a few basic programming definitions just to kind of set the stage. Awesome. Taking the AI. Oh, yes. One of the attendees tonight is taking our artificial intelligence boot camp. I am telling you right now, you just made a very smart career decision. It's very early days in AI, but I've been doing this I've been programming honestly for 43 years, and I've been paying attention to the technology industry for about 40 years, really closely paying attention. This is one of the most fundamental, powerful, impactful changes in the tech industry and the business world that we've seen since the web in the very, very early 90s. It's massive. Getting trained in being a computer programmer and artificial intelligence is a huge differentiator in your career. So I'm really happy to see that, Evan. That's fantastic. All right. So basic definitions. A program. This is a series of written instructions that you can put into a computer and they'll make the computer do something. It's that simple, right? You write these instructions in a special language that is called a programming language. Now, this part's important. All it is just text. We've used text a million times in writing, in using computers. We type in text messages, in emails, in creating word processing documents. We write text all the time. And it's just really important to understand before we go, too deep into this, that when you're writing in a programming language, you're writing text. That's all. Oh, by the way, I didn't make a note about this earlier because we rarely have people joining from a mobile phone. But I see someone joining from a mobile phone. If you're on a phone, you won't be able to do the coding portion of the program just because it doesn't really work on a device that small, right? But you'll still get a lot out of it, right? Also, whoever's on the phone, the iPhone, I saw your note, and technically you're right. We don't break that down in this time period just because we have about an hour and a half. That's spot on though, okay? So this programming language is an organized system of words, phrases, and symbols that let you communicate with the computer and tell it what to do, right? So you use programming languages to make programs. And finally, let's cover the word coding. That's the action of actually putting those instructions into the computer. That's all coding is. What does it look like? Well, you're going to do some tonight. It just looks like typing words into a document. It's actually that simple. You're typing some words into a document. And yes, there's some stuff that goes on under the hood, and we'll cover that. But he's typing words and symbols into a document, okay? So let's get a little more precise. We're going to cover 3 different technologies right now, starting with JavaScript. I'll explain the significance of these 3 technologies in a moment. JavaScript is a super popular programming language. It's been around for almost 30 years now, okay? And it can be used to create computer programs and also to make web pages really interactive, make web pages have a lot of functionality. So JavaScript's very versatile, right? The other technology I want to cover is HTML. Now that stands for Hypertext Markup Language. A full breakdown of what all those words really mean would take, probably 15, 20 minutes to fully flesh out. So I'll just say this. It's another language that you can use to describe what is a web page going to look like. Like, what's the content on it? How is the content presented? Whether the content is text or videos or images, tables, diagrams, whatever. HTML is how you lay out what's going to be on a web page. And finally, CSS, which stands for Cascading Style Sheets. This is a really cool language or technology that we can use to control, now that we have a web page, we can control its appearance. What font is used? How big or small is the size of the text? Do the images on the screen have borders around them or not? Are there any cool like drop shadow effects where it makes it look almost 3-dimensional? All these things and many, many more can be controlled throughout your whole website using this language called CSS. So these 3 technologies, while they all exist as themselves, they're very often used together. And these are the technologies of the web. This is how you make web pages, control what they look like, and give them added functionality, is these 3 technologies. But JavaScript isn't just for web pages. As I said, you can build full-blown computer programs that can do all sorts of things. Customer service rep programs or inventory management or whatever. You can write these with JavaScript. And this is a JavaScript class. So the code you're going to write in a little while is going to be JavaScript code. Any questions so far? Go ahead and drop them in chat. All right. Now, I have a very strong opinion about this slide. I don't hold back on this at all. And it's just my opinion. It's up to you to decide whether or not it's true for yourself, okay? The information I'm going to present on this slide is one of the most valuable pieces of information in computer programming. If you learn these 5 elements of a computer program and you learn them well, every bit of your technology training and actual work on the job will get better. Obviously, that's a pretty strong opinion, but I've been doing this for a long time, and that's just how I feel about it. Now, there's 5 basic elements of any computer program. We're going to go through them very briefly, but you're also going to use most of these in our coding today. The first important element of a computer program is the entrance point. In other words, what's the first instruction in the computer program? This matters for 2 reasons. The first one is kind of like behind the scenes, and it just helps the computer that you're running the program on. It helps that computer control some of the memory devices in the computer that are needed for your program. Your program works with data. If your program is like tracks inventory for a warehouse or keeps track of students for a school, your program is working with a bunch of data. And there needs to be a place to store the data the program is working with. And inside your computer, they have little devices called memory devices or memory storage devices, which is where this information is when your program's running. So when you start a program, when that first instruction begins, the computer reserves some of that storage location for you. It might say, hey, these 1 million locations are only for this program that just started up. They're only for Erik's program, and no other program can touch these locations where we're storing data. It keeps the data safe. Now, that's kind of interesting or not, depending on your point of view. But here's the part that should be interesting for you as a technologist, for you as a developer. Knowing that there is a first instruction in every program and figuring out how to find that instruction can be super valuable to you. In particular, when you get on the job, you join a team, and you and that team are responsible for maintaining, say, a really large computer program that's been around for a while. You are, of course, going to want to try to understand, what is this program? How does it work? What does it do? And one of the most valuable things that you can do, from my experience, is to find the first instruction in the program. And it doesn't take long, a little bit of a Google search, a little bit of ChatGPT help, and you can find, for this specific type of program, written in this programming language, where will I find the first instruction? And you go there in the code, you go there in the program, and you start reading through one step at a time. There's no better way, in my experience, to start to figure out what a program does and how it works, and what was the mindset of the person or team that created that program, than starting right at the beginning. So, an important element of a computer program is the entrance point. Another important element of a computer program is what we call variables. This is just pieces of data that the computer program is using to keep track of information that changes while the program is running. Typical example would be playing a video game and you've got a score, right? Let's say it's a racing game and you're keeping track of how fast you completed a particular racetrack. Well, that information changes. Each time you play run the race on that track, you've got a different time. Variables keep track of this information. It's super valuable. And frankly, without this in a computer program, without a way to keep track of data that's changing, your computer program has very limited utility. It's of little value to people. And we're really only writing programs to be of help to people, to help them do things faster, in a more, less error-prone way, right? To help you be more productive. We're here to help. And programs aren't very helpful if they don't have variables. Next element of a computer program to look at is what we call control and branching instructions. This is how you get a computer program to make a decision. And we're going to look at this in some detail when we write some code in a few minutes. But without the ability to tell your computer program to make a decision, your program isn't very valuable. We often have to make decisions when we're processing information manually, like as a human being. Computer programs need the same utility. They need the same ability to make decisions. And so control and branching is a vital element of a computer program. We're getting towards the end here on these 5 elements, but this one's pretty important. It's called a subprogram. As it says on the screen, you can think of a subprogram as a program within a program, right? But it's this concept, basically. What if there was a series of, say, 5 instructions, and you found yourself, when you were building a very large program, repeating that exact series of, say, 5 instructions over and over again at various points in your large program? Well, that produces a couple of problems. One is that it's kind of error prone. You have to do those 5 things the exact same way each time. It could be kind of easy to make a mistake. But the other big challenge is, what if you later on want to change the way those 5 steps are done? You change one tiny piece of it. Well, now you have to go to every single spot in your big giant program that you've done that exact series of the same 5 instructions. You have to change it in every single location. Not only does that take a lot of time, but it'd be really easy to miss one. Subprograms handle that. And we're going to look at those tonight as well. Finally, the 5th vital element of a computer program is the exit point. This is, when is the last instruction of our program performed? And this is important for a few reasons, most importantly under the hood in the computer itself. Remember, at the beginning of the program's being run, when you start up the program, Your computer reserved some of the locations in the memory storage devices in the computer and said, hey, only Erik's program can use these. Well, now that you've reached the exit point, now that you've reached the final instruction in the program, the computer can go, oh, never mind. All those memory locations are all released and other programs can use them now. So it's an important thing to know. So there's your 5 elements of a computer program. I want to stress 2 things. One, they're not presented in an exact order. Other than number 1, the entrance point, and number 5, the exit point, those are the only ones that have to be in that exact order in a program. The ones in the middle, you make use of those however you need to in whatever order in a program, and you're going to see that tonight. All right. Let me take a sip of water and move on. Gracie, can you do me a favor and drop this link into chat? Go ahead and click on that link if you would, folks. What this is a code editor, a place to write your code. And when you click on it, you're going to see something like this, the one on the right here, okay? There's 2 of them side by side for a reason. But this is a code editor. Now, we'll get into how it works in a moment. But here's the important thing. I want you to be able to see what I'm typing and what you're typing at the same time. Yeah, if you have 2 monitors, that's easy. Put the code editor that you just opened up on one monitor and put me on your Zoom call on the other monitor, okay? Oh, Gracie, you sent that to hosts and panelists. Let me send it to everyone. There you go. I get it. All right, I'll give everybody a minute to click on that. I apologize. Okay, good. So, again, this is your code editor. I'm showing 2 of them side by side. And that's what I want you to be able to set up. I want you to have your code editor that you just opened up on the right. And I want you to have me on the left, because in a moment, I'm going to have a code editor as well, okay? So, set up Zoom on the left and your code editor on the right. If you need to resize Zoom, sometimes you have to click on this Zoom meeting text, and a little button that says restore comes up. That can help you resize your Zoom meeting and move it around. And with your browser, sometimes you can click on the little symbols in the top right that look like squares right here, and that'll help you resize it. So I'm going to give everybody a moment to get set up to have me on the left in Zoom and your code editor on the right. And I am going to now show you mine. Okay, can everybody see? I'm looking at chat. Can you see my code editor? Let me know in chat. Okay, good. Excellent. Thanks, Matthew. All right. Now, first, I just want to show you how the game works. Don't worry about all this code. You're going to see this yourself later on. All right. So this is the Pong game. I am moving the blue paddle with my mouse. You can see me move that. Oh, I lost. Okay, good. All right. So that's the Pong game. Now, I'm not going to go into any detail in here. There's a bunch of code in here. We'll look at this later, okay? Just want to show you that that's the game, okay? Now, what you should see is what, let me go and make this a little bit larger. Okay, now, here's the code on the left. Let me explain a couple of things about what you're seeing, okay? So everybody, don't worry about typing anything. Just pay attention, if you would, to what I outline on the screen. I just want to call your attention to a few things. The first thing is that overall, all of this text that you're looking at is written in HTML, or hypertext markup language. It's one of the things we described earlier, okay? It's the way to describe or to lay out the content of a web page. Now, you'll notice that some things are colored differently, right? The text, sometimes it's black, sometimes it's red. Sometimes it's brown, sometimes it's blue. The only reason that's done is to make it easier for you as a human being to read through this and separate different types of things in the text. I want to, again, stress this is just a text document. There's no magic to it at all. Okay. The third thing I want to stress is what goes in between this thing that says script and this thing that says /script. In other words, look at what I've highlighted right here. That is an actual computer program written in JavaScript. It's not a very big computer program. It's got 4 instructions, and we're going to cover what those things mean. But that's a computer program. All right. Now, what I want you to do, go very slowly and carefully. I want you to highlight the exact content I have highlighted and then delete it. I'm going to go Control Z so you can see that. I want you to delete that content. Because right in between these two things that say script, this is where we can write a JavaScript program and we can actually get it to run. You can write a program and run it. And we're going to start creating our little program with the first instruction. And it's going to be pretty simple. We're going to create, we're going to cause an alert to pop up. Now, what's an alert? Well, you've all seen them, even if you didn't know the actual name of it. It's a little box that pops up in a web page that has a message. JavaScript actually has a built-in instruction to make one of those little boxes pop up, and it is alert. So type ALERT, and then do an open parentheses and a close parentheses, and then a semicolon. Don't run this program yet. Just want to explain what we're looking at. This is a JavaScript instruction. And what this instruction does is it tells the computer, please take all of the content inside these parentheses. And yes, I know there isn't any content there yet. This JavaScript instruction says to the computer, please take the content inside these parentheses and put that content inside a little box that pops up on the screen. That's what this instruction does. Now we need to give it some content. We're going to give it content that is a certain type of data. There's several different types of data you can have in a computer. You can have number data, like integers or decimals. You can have date data, like dates and times. And you can also have text data, which is just letters and numbers. We're going to give some text data and make it be in the box that pops up. Text data inside a computer is wrapped in double quotes. So put 2 quotes and then make your cursor go right back in between those double quotes. Pay close attention to where my cursor is. The cursor is the flashing bar. Now, we're going to have several of these alerts pop up one after the other. This is the first one. So I'm just going to put a 1. And I want to have a message pop up and say, Erik needs coffee. There we go. I'm just putting something there. And finally, I want to explain this semicolon right at the end. In JavaScript, the semicolon is used to tell the computer the current JavaScript instruction is done. Like everything right before this on the line, on this line, I'm done writing my JavaScript instruction. Please perform the instruction. That's what that means. So let's run this. Go ahead and look at this button up here and it says it's green. It says run. Let's run it. And hey, look at what happens. This box, it's called an alert box, pops up and it has our text content in it. If yours did not work, let me know in chat. Okay, good. All right, now go to the end of that line of code. You see where my cursor is and hit enter again. And now we're going to start using variables. Again, a variable is just a piece of data that can change as we play the game. Okay. Now, one of the things that you might want to keep track of, say in a Pong game, is how many times your paddle has successfully intercepted the ball. We could call that a hit, right? Each time your paddle hits the ball. So let's make a variable. And in JavaScript, there's a special instruction for that. It's called var, V-A-R. That means create a variable. And they have to come up with a name for the variable. We're going to call ours hits. Now, we're going to type the rest of this instruction, and then I'll explain a bit of what it does. Give me the symbol that says equals. And then we'll have, say, 0. And then give me a semicolon. And I'll explain every part of what's going on here, okay? First, never mind what's on the screen, and never mind how an actual computer works. I'm going to use a parallel here, an analogy. A variable is kind of like this. Let's say you have a big wide open field, and on that field are a million small buckets, like the buckets you might take to the beach to play in the sand. And you have information that you want to store in one of these buckets. You could pick one of the buckets, and on the outside of the bucket, write the name for the information you're going to store. Let's say it's you're storing the player's name in a game. You could write on the outside of that bucket, player name. And then on the inside of the bucket, you could put a piece of paper that says Erik. And there could be a million of these, say, in a big wide open field. That's pretty close to how these memory devices, these physical devices inside your computer, actually work. They're called RAM. It stands for random access memory. Many of you might be familiar with that term. And they're just thin sticks that are about 3 or 4 inches long. Usually they're black with a gray, a gray background, or sorry, a green background. And they stick inside your computer, inside the actual box. But what they really are is like that big wide open field. They're little devices that have millions or often billions of tiny little electronic circuits that act like those buckets where you can store information. They call those memory locations. But it works the exact same way. You have to tell the computer, hey, pick one of those locations, give the location a name, like player name, and put the information in that location, like Erik. It's the same kind of thing as a bucket. Well, let's get back to our code. That's what we're doing right here. We're creating a variable called hits. In other words, we're telling the computer to find a location in the memory and call the location hits. And then we're telling it further, put the value 0 inside that location. Now let's get to the exact terminology so that when you encounter this later in your studies, you know what these two terms mean. What we're doing right here is we're declaring a variable. That's called declaring a variable. Dakota, I'll get into that. That's a bit beyond the scope of what this class is. It essentially does the same thing. There's just a little bit of nuance. She was asking what's the difference between var and let. And that gets into a bit of a deeper dive into some of the nuances of JavaScript that are beyond this class. You can kind of think of them as roughly the same thing for right now. They both let you create variables. You'll learn all about the difference between them on our JavaScript bootcamps. All right, so the part that's highlighted again is called declaring a variable. And this instruction tells because there's two instructions on this line. There's before the equal sign, and then there's equal sign and after. The before the equal sign is called declaring a variable. We are telling the computer, find a location in the memory and call that location hits. And then there's these symbols. The equals symbol is called assigning a value. We assign the value of 0 to the variable we just made. And this instruction tells the computer, hey, you know that memory location that I told you to find and give it a name called hits? Good. Put the number 0 in that memory location. And more importantly, from now on, whenever I reference this variable called hits, what I really want you to do is give me the value stored in that location. I want you to give me 0 if that's what's in there. But whatever's stored in that location, I want that. When I talk about hits, what I really want is what's the information stored in that memory location. So we now have a variable. Let's use it. Let's do another alert, A-L-E-R-T. Remember your open and close parentheses and the semicolon. Then go back, and let's give ourselves a double quotes, and then go back. And now this is, again, the second alert we're going to pop up. So I'm going to do 2. I put these numbers just to make it easier for you to keep track of which alert corresponds to which part of the code. That's the only reason I do that, okay? So here we're going to say your paddle has hit the ball this many times. And now I'm going to type this stuff out and I'm going to explain it. So just follow along very closely. You hit a space, hit the plus symbol, hit space, type S, T, R, do the parentheses, and a close parentheses. That part's super important. And put your cursor in between. I'm going to leave that there for a moment so nobody gets lost. We're not done, but I want everybody to be able to catch up. So you'll see there's actually 2 closed parentheses here. So go in between the open and closed. And now I want you to type the name of our variable. I want you to type hits. Now I'm going to explain what I'm trying to do here. You can almost read it. It almost reads like English. Clearly, I want to tell the user how many times their paddle has hit the ball. Seems pretty straightforward, right? And we already know that if I refer to a variable, in this case, the variable is called hits. We know that if I refer to the variable, what you're really saying to the computer is, hey, give me the value stored in that variable. Right now, that value is the number 0. But that's the important part. It's a number. We have a piece of information stored in that variable, which is number data. It's numeric data. This next little bit right here can sometimes really trip you up if you're new to figuring out computer programming. I want to go back to when I explained this first line of code. In particular, what I said was that the instruction called alert tells the computer to do the following. It says, look inside these parentheses. There you will find information. More precisely, you will find text information. Please display that text information in the pop-up alert. Well, text is one type of data that a computer can work with. I mentioned that. And numbers are a completely different type of data. Here's why we did this weird thing with this str that I'm going to explain in a moment. The alert instruction can only be given text information inside these parentheses. Our variable called hits doesn't contain text information. It contains numeric information. Well, luckily, JavaScript has another built-in instruction called str. And all that does is if you give it number information, which we have, it turns that number information into text information. Text information is also called string information in a computer because it's strings of numbers and letters all connected together. A, B, C, D, E, F, G, 1, 2, 3. So text information is also called string information. And so this instruction, because str is an instruction, all it does is if you give it number information, it turns it into a string. And that's why all that code is there. So let's run this. Here's our first alert. We already knew about that one. That's from the alert instruction right here that I'm hovering over. And then click OK again. It didn't work. I have an error in my code. Alert. Quote, quote, plus string hits. All right. I think my syntax might be off. Give me a moment. I don't memorize syntax. That's another real important lesson I learned decades ago. Is never memorize the syntax or rules about the language. You can always look that up. So let me look that up on my other screen. Oh. Okay, I know what I did wrong. Okay. I was teaching a Python class the other day, and this is how Python does it. So erase that whole str thing. I'm getting everybody a chance to get caught up. There's the function I got was wrong. The built-in instruction I got it wrong. In JavaScript, it's this. Type the name of your variable. Our variable is called hits. So type hits and then do dot to, and the capital S, string. Make sure you get it exactly like I wrote it. And this part's important. Do an open close parentheses right after the to string. Should work. All right, it worked. So this is a built-in function or built-in instruction in JavaScript that takes a variable with a number value and converts it to a string value. Any questions so far? Drop them in chat if you have questions. All right, now let's talk about a couple other pieces of terminology. Well, one really important piece of terminology, okay? Look at all the information inside these parentheses. We are taking this instruction, it's a JavaScript instruction called alert, and we're giving it information. All the information inside the parentheses is being given to the instruction called alert. Well, there's a technical term for that. We call that passing the information into the instruction. We are passing in the information inside the parentheses. That's the term, passing it in, okay? Or pass it. All right, now let's get into a little more fun stuff. Go to the end of this current instruction, hit enter. And now we're going to go into control and branching. Remember, this is how we're going to tell our computer program how to make a decision. We're saying to our computer program, listen, I'm going to tell you to make a decision. I'm going to give you the information you need to make the decision. And I'm also going to tell you which of 2 or more possible things to do based on the decision. In other words, you're giving the computer a fork in the road. You're telling the computer, stop. I need to control what you do. I'm going to set up 2 or more branches. In other words, 2 or more possible series of things to do. And I'm telling you, the computer, to decide. Here's the information with which to make the decision. That's what we're going to, that's in plain language. That's what we're going to build. To get a little more precise, we're going to set up control and branching instructions. One of those 5 fundamentals we talked about earlier. Now, in JavaScript and in many languages, one of the more important control instructions is a simple instruction called if. So type in if, and then give me an open and close parentheses right after it, and put your cursor inside the parentheses. All right. Now, before we put anything inside these parentheses, I want to show you what's going to come after. Go to the very end of the line, hit enter. And now I want you to type what are called an opening and closing curly brace. Now, curly braces don't get used that often. They are above the enter key. And they are what happens when you hit shift and hit the square bracket key. That's a curly brace. Then I want you to enter another couple times and do a closed curly brace. Make sure you get the curly one, not the square one. Then hit enter and type else. Hit enter, give me an open curly brace. Hit enter a couple times and give me a closed curly brace. Now, there's a lot more stuff we're going to type in here, but I'm showing you a mental structure to think with. Wait till everybody catches up and take a sip of water. Now, again, we're not done writing this part. I'm deliberately leaving a lot of the pieces inside of this empty, just to illustrate something for us. Remember that we talked about this in that slide called the 5 elements of a computer program, right? And we said that one of them was control and branching. Well, the control part is this if instruction and this else instruction. That's what controls which of 2 or more possible courses of action are going to happen. And then we said there's control instructions and there's branches. The branches are the what can happen. They are inside these curly brackets. We're going to put code inside these curly brackets. The code that's in this one right here, the top set, is only going to happen if something's true. Otherwise, we're going to do what's in this lower course, or this lower set of curly brackets, this lower branch. So a simple example, we're not even going to write this out in code, is if age is 21 or greater, then sell them alcohol, else don't sell them alcohol. Now, for those of you who aren't in America, it might be a little different for you, right? I think if you're in England, you can start drinking at age 5. But that's a joke. I think you have to be like 18 or 16 or something. The whole point is, it's a very clear-cut decision. There's no ambiguity. There's no ish, no maybe. It's cut and dry. If you're 21 or older, you can buy the alcohol. If you're not, you can't buy the alcohol. That's the way to think when you force a computer to make a decision. This part's super important. Computers are stupid. Computers will only do what you tell them to exactly. And if you don't tell them what to do, they'll stop. Like, I haven't been given any instructions for this situation, so I'm just going to end off and go, help. Because computers can't think. They can't figure out, well, this is what I really meant. No, they can only operate on what they were told. And that's super important to realize as a programmer. So what we need to do here is we need to give the computer a decision to be made, which we're going to get to in a second, and the 2 courses of action to take based on the decision. Ooh, man. I'm not sure who's coming in on the iPhone, but you have really good questions. Is that, yeah. What's your name? Person joining from the iPhone, drop it in chat. I want to be able to refer to you by name. The question was, with AI, will that change how computers function? Lisa, brilliant question, and I'd love to talk about it at length. Okay, so all I can do is just give a very short answer. Fundamentally, no. With the way computers are physically constructed, there's no way at all in the physical universe for them to make a decision that hasn't already been outlined for them. They can't, quote unquote, figure out what to do. Now, that said, there's some very sophisticated types of computer programs that make it look like the computer is actually deciding what to do. But the fact is, they were given instructions way ahead of time on, hey, if you encounter a situation with these exact criteria, here's the tools you can make to come up with a possible course of action. And you should do that when you come up with the course of action. The computer is still being told what to do. That's the very short version. I'd love to dive into that a lot more deeply. The area you want to look at, if you don't already know about it, is called machine learning. But Lisa, that was a very insightful question. Again, she said, with AI, will that change how computers function? And the answer is fundamentally no. Physically, computers can never do anything they weren't told to do. They have to be told exactly how to act in any given situation. But the sophistication of machine learning computer programs makes it look like they're actually coming up with what to do on their own. I assure you they're not. And the biggest reason why, there's no spark of life or creativity inside a computer. It's ultimately just a machine. It can never decide to do a thing. It is a reactor, not a cause-or. Okay, good. Love that question, Lisa. Thank you. All right, so now that, like I said, we built out this sort of little like sketch or template, it's like a framework. Remember again that if and else are the control instructions, and the branches go inside of these curly brackets. Let's figure out, what are we going to tell it to make a decision on? Well, I had to come up with something, and I thought, well, let's just say that, and I'm just making up a situation here. let's say we're offering this Pong game for free, but we don't want to let people play it forever or like play for 5 hours. Let's say that they can only play till they reach 100 times that they've hit the ball with the paddle. After that, sorry, game over. Okay. Again, I'm just coming up with a situation. You don't have to design a game like that. But if we want to do that, we have to figure out, as the programmers, we've got to figure out how to implement that. We've got to tell the computer to make a decision. We've got to say, hey, computer, I've been telling you to keep track of how many times the player's paddle has hit the ball. If the player's paddle has hit the ball 100 times or more, then you need to stop the game and tell them game over. If not, let them keep playing. Now, again, it's a fully made up situation, but that's a situation we're going to pretend we have. How do you get the computer to do that? Well, the first thing you need is you need a way to keep track of how many times has the paddle hit the ball. Hey, we have that. It's up here. We created a variable called hits. Okay, good. So the next thing you need is look right inside these parentheses after the if instruction. Remember, the if instruction is our control instruction, and we're going to tell the program to make a decision. Here's the decision we're going to make. I'm going to tell it to make. I'm going to type all this out. You follow along, and then we'll explain it. HITS, hits, space, and then do 2 equals symbols, then space. Oh, wait, sorry, not 2 equals, do greater than and equals. The greater than is to the left of your shift key, and then 100. Let's explain what we're looking at here. Hits is our variable. We already know that. We made it up here. These 2 symbols are what are called a comparison operator. A comparison operator tells the computer, hey, you're going to be given 2 pieces of data. I want you to compare them and tell me something about the 2 things. Here, we're specifically saying you're going to be given 2 pieces of data. I want you to compare them and tell me whether or not the one on the left is greater than or equal to the one on the right. That's all you're doing. And of course, on the right, we have our limit. No one gets more than 100. Actually, you get 99 turns. As soon as you hit that 100th one, you're done. The 100th hit, that's it. So this part right here is called our condition. If this condition is true, then do what's in this set of curly braces. Otherwise, do what's in this set of curly braces. So what are we going to do? Well, go in between the 2 curly braces, and I want you to hit the tab button just to make your code a little more readable. The tab button doesn't do anything in terms of your program. It just makes your code a little easier to read. So you hit tab once, and then all we're going to do is we're going to pop up an alert that says, sorry, game over. So type alert, and in parentheses, and a semicolon, same thing. Go back inside the parentheses and go, do double quotes, say, sorry, game over. That's it. Then go down here to the curly braces after the else instruction, hit tab once, and here we'll do a different alert. Keep playing. Like that. I'm going to leave that on the screen for a moment for people to catch up. All right. So what's this program going to do now? Any guesses when we run this? What's going to be printed on this final alert that pops up? Don't run it. Don't cheat. Don't run the program. Just tell me what you think. Yeah, absolutely right here. Keep playing. Let's run it. Run. Here's number 1. Click OK. Here's number 2. Click OK. Keep playing. Right. Good. All right. Now, go up here to your variable called hits and make it equal to 100. Now run your program. 1, Erik needs coffee. Always true. 2, your paddles hit the ball this many times. 100. And then click it again. Sorry, game over. So I know it seems like a relatively simple, silly, made-up example that Erik just pulled out of his head, but this fundamental structure is super powerful. You have successfully told a computer to make a decision. You've given it the criteria on which to make the decision, and you've given it 2 or more possible courses of action or branches to do. And it worked. Your computer did one thing based on one situation and a total another thing based on another situation. That's pretty valuable. Okay. Now, let's move on to our final cool thing we're going to demonstrate in code. These are the things we called subprograms. Again, a program within a program. Let's say, for example, that we need to make this check every single time the player's paddle hits the ball. Every time. I don't know about you, but I don't want to type this code that I've highlighted 100 times in my program. Now, I know it's a clunky way. You wouldn't really have a program that every single time you hit the ball with the paddle, an alert popped up. I'm just using this to illustrate a concept. We have highlighted right here, highlighted on the screen, is a decision that in our made up situation, it's a decision our program has to make over and over and over and over again. And every single time the decision is made, the situation could be completely different. The number of times the paddle has hit the ball could be completely different each time. And like I said, we don't want to write this thing 100 different times inside our program. Well, let's turn it into a subprogram. Let's make, it's almost like this. We're going to take these instructions that you see highlighted on the screen, the ones in purple. You're going to take those instructions and you're going to put them in a little box. And you're going to put a name on that box, and the name of that box, we're going to call that name check complete. I just came up with that name right now. We're going to call that box check complete. And inside that box is these exact instructions. And from now on, every time in our computer program that we want to check whether or not the game is complete, all we do, instead of typing out all 1, 2, 3, 4, 5, 6, 7, 8 lines, instead of typing out these 8 lines of code, we type out 1 line of code. And it basically says, hey, go do what's inside that box. That's how a subprogram works. Let's build it. Go down to the end here after our last curly brace. And I want you to hit enter here just for readability, because we're about to make a subprogram. Now in JavaScript, we call them functions. Different languages have different terms for the same concept. Functions, methods, subroutines, subprograms. It all means the same basic concept. In JavaScript, they're called functions. So let's make a function. And guess what? The way you do that in JavaScript is you have a special instruction called function. So type that, hit space. And now we have to give a name to our function. We're going to call it check underscore complete. The underscore is what happens when you do a shift on the hyphen key. Check underscore complete. Now this part's important. Don't hit space yet. do an open close parentheses, and I want to talk about a super important part of computer programming. So I'm going to give everybody a moment to get caught up, and please pay attention to this next part. When you create your own functions, your own subprograms, sometimes that function needs to be given information in order to do its job. And sometimes it doesn't. But either way, in virtually every programming language, you have to indicate right after the name of the function whether it's going to receive information or not. And you do that by putting these open and closed parentheses inside it. And if, in fact, your function is going to need some information when you ask it to do its job, you have to come up with the name of a variable here that's going to be used for that information. So I'm going to have a variable here called number of hits. So type that in. And what this means is later on in my program, every time I want this function called check complete to do its job, I have to give it some information. And it means as well that this function check complete is going to give the information. Let's say it's the number 10 or the number 99. It's going to make a variable called number of hits and assign the value that I gave it. It'll give it the value of 10 or the value of 99. We'll see that in action in a moment. But once you're caught up, let's do the next part. Go to the very end of this sentence, hit enter. This part's super important, and do the open curly brace, enter a couple of times, and the close curly brace. Because what you're about to do is you're going to put some instructions inside here. And a lot of people, when they're first learning the program, this next spot, again, really trips them up. What goes inside of these curly braces are the instructions that will only occur if later on in the program we ask for this function to be performed. So inside these curly braces, we're about to write some instructions, but they're not going to automatically happen. They only happen if you, the programmer, ask them to happen later on in your code. But the instructions that we're about to put in here should be kind of familiar to you. We're just going to check whether or not the number of hits is greater than or equal to 100. So watch carefully. Look where my cursor is right here in between the curly braces. Hit tab just for readability and do an if. And we're going to take our variable that we received, number of hits, spell it exactly right, greater than or equal to 100, and do an end parentheses. Hit enter, open curly brace, enter a couple of times, close curly brace, go back in between those, hit tab again, just to make it more easily read, and we're going to do an alert. And we're going to say, you reached 100 hits, game over. Double quote, parentheses, semicolon. I'll let you get caught up. Now go down and go to the end of that second curly brace, hit enter, and do an else. You should get used to this pattern a little bit. We've used it already. Hit enter, open curly brace, enter a couple of times, close curly brace. Go back in between the curly braces and hit tab. This time we're going to do an alert. And it's going to say, you can keep playing, exclamation point. Double quote, end parentheses, semicolon. Now, don't hit run, please. In chat, please answer the following question. What is the message in our final alert going to say when we run this program? What's the exact message? Ryan, that's not right. Dakota, that's correct. Nope. Matthew, that's not right. Mark, that's not right either. Okay. Ryan, that's exactly right. Good job. Now, again, don't run it. Okay. Now let's run it. You're going to see what the final message is. And I'll explain why it isn't what many of you thought. And it's actually, there's no intention to make you wrong for this at all. The error in thinking that you had is one I had when I first learned to program. And so that's why I stress it so much. Let's go ahead and run this. So here's number one, Eric needs coffee. We expected that one. Click OK. Here's number two, your paddles hit the ball 100 times. Click OK. Here's the third one. It says, sorry, game over. Don't click OK yet. Why does it say that one? Well, look, we set the value of the variable hits to 100. And then we said if the variable called hits is greater than or equal to 100, then pop up an alert that says, sorry, game over. Some of you expected that when we click OK, another alert would pop up that said, you've reached 100 hits, game over. Click OK, and you don't see that. Now, there's a couple of... Lisa, are you on an actual iPhone? Lisa said hers isn't working. Let me know, Lisa. All right, so let me explain this part. This is super important. And by the way, if you're able to write the code and it's not working, Lisa, look at every single character. Oh, good. Okay, she's on a laptop. There's something about what you have written that isn't identical to mine. And sometimes you have to look very closely. Sometimes it's you misspelled a variable. You have it here, but it's different here. Okay. Okay, so let me explain exactly what's going on. In my experience, there's two reasons why you would think that this alert should be the last one we see. Good catch, Mark. Here's the first reason. You think, oh, well, the number of hits is 100. And we're checking whether the number of hits is 100. There's two errors in reasoning there. Here's the first one. This variable is called hits. Is this line of code checking the value of the variable called hits? No. It's checking the value of a completely different variable called number of hits. This variable number of hits has nothing to do with this variable. So that's the first thing to think with. But here's the real reason. Look at the code that I've highlighted right here. That code never even runs. That code, those instructions never get performed. Why? Because these instructions only get performed if we ask for the function check complete to run. And that's not what this does. All this section of code that I've highlighted does is it describes a function that could be used in the future in your program. It could be used later in your program, and that's super critical. A function only describes potential behavior available later on in the program. That's all it describes. In order to actually get that function to run, you have to add a whole nother instruction asking for it to do its job. Absolutely, even. Glad you could help. Or glad I could help. Well, let's do that. Go to the very end. See where my cursor is, right after the final curly bracket. Hit enter just to give yourself some space. And now let's actually call our function. You do that by just typing the name of the function. Check underscore complete. And now this part's important. We have to give it some information. Let's pretend that the paddle has hit the ball 50 times. So pass in the number 50. Like that. What we are telling JavaScript to do with this line right here, this line says to JavaScript, hey, you remember that function that I gave you called check complete? I want you to actually do it now. And I'm giving you this information, 50. So go to the function check complete, take the information I'm giving you, 50, and give that as the value for the variable number of hits. And then run the instructions inside the curly brackets. So JavaScript does that. It says, oh, I've got 50 here. All right, let me start running check complete. And I'll set number of hits to 50. It says if number of hits is greater than or equal to 100. Oh, no, number of hits is equal to 50. That's not greater than or equal to 100. So I'm not going to do this. And then it says else do this. Oh, I need to do this. Let's run our program. There's number one, number two. There's the sorry game over that we expected from up here. And then you can keep playing. Look at that. The correct branch was performed. And it only happened because we asked for the check complete function to run. Click OK. Now go down below, hit enter again after our check complete. And let's say it's been a little while and the person's still playing, and all of a sudden, they hit 100. We're calling the function again. Run it. Erik needs coffee. Your paddles hit the ball 100 times. Sorry, game over. That's still from up here. Okay, good. That's when we were at 50. We can keep playing because we're only at 50. Hit OK. Sorry, you reached 100 hits. That's from this time that we called the function. Now, what's really cool is this one line of code right here ended up performing these 6 lines of code just like that. And then later, we called it again with one line of code. We actually ran these 6 lines of code again. Now, one last cool demonstration. Let's say that the designers of the game said, you know what? We're just being kind of mean when they've reached 100 hits. I want to soften the blow a little bit. I want to say, hope you had fun. I want to say, I hope you had fun once they've reached 100 hits. Now, let's say I wasn't using a function. Let's say I had used something like this code 100 different times throughout my program. I'd have to go to every single one of them and go, all right, well, see, what did I say? You can, or hope you had fun. I'd have to go find all 100 places that I had done this set of instructions, and I have to change every single one of them. And I'd be going out of my mind, and I'd probably miss some. But now, because I wrapped up this logic in a function called check complete, I just need to go and change it in one place. Hope you had fun. And now it's changed everywhere else in the program that I use this function. Makes it very, very versatile. All right. Now, let's give you all of the code. Gracie, can you drop? Oh, I've got it right here. Super handy. I'm just going to go here, drop this link. Grab that link, and you should be able to grab this code. I want you to Control A, Control C, so you copy all of it. Go back to your editor. Do Control A, delete everything, and do Control V to paste it. And I want you to play the game for a minute. If you're not able to play the game, let me know in chat. Oh no, I missed it. All right, now. We're not going to go through this whole code, but I just want to point out that a lot of this should be relatively, like, you can start to understand a little bit about what's going on. You can see things like, if we go to the top here, remember that our JavaScript program starts with this section called script right here. Const is another way to create a variable, and let is another way to create a variable. So we're making a variable called canvas, making a variable called CTX, a variable called logo, a variable called score. That's kind of important. Okay, a bunch of variables. All right. And look, we're making a bunch of functions. Here's one for drawing rectangles. Here's one for drawing circles. Here's one for drawing the logo. Here's one for detecting collisions. Here's one for moving the paddle. All these functions. Well, you know about functions now. And then here's a function called game loop. Huh. In green, we see something new. These are comments. They don't do anything for the computer. They're just there to help you understand the code. Main game loop updates and renders the game. It's a function called game loop. Basically says if the game is not paused, run the function called update and then run the function called render. Oh, there's the function called render. In other words, you could start to read through this code, and even though it'd be kind of rough at first, you can recognize some of the fundamental elements of what's going on. Now, obviously, this is an hour and a half, okay? We can only impart so much. But with more instruction, and especially going through one of our boot camps, you can understand literally every single piece of this program. All right. Let's get back here. Okay. So I tried to watch for questions. Give a quick second here. If you have any, open up the floor for any other questions before we move on. I'm watching chat. Anybody got any questions? Okay. All right, now stick around for your free gift. I think you'll really like this. If anything about doing this coding challenged you, excited you, frustrated you, enjoyed it, like if it gripped you in any way, you're gonna love the free gift. So, who and what are we? Well, what we primarily do is we deliver boot camps. In fact, we have 12 online boot camps. You can see the subjects here. We cover all sorts of different things. Okay. Oh, Ahmet, phew, that's way beyond the scope of this class. How can I create 3D animation shapes with a technology I'm not even going to give you the name of because it'll just confuse everybody. I can't go into that in this, but I will tell you, you should probably join our Tech Academy Accelerator, which Gracie can give you a link to. Gracie, can you share a link to the accelerator with him? Because that's something I'd love to do in the accelerator. It's just way beyond these free classes. Okay. 3D animation is like, I can't do that in an hour and a half. All right. So back to these certification programs. Like as you can see, we have a bunch of them, right? There's a couple of them I really want to call attention to because they're such huge differentiators in today's technology industry. I already mentioned the Artificial Intelligence Developer Bootcamp. It's exemplary, very valuable bootcamp to go through. Okay. Game developer can be a tremendous passion for a lot of people, and our game developer bootcamp is very good. We've gotten people hired at all kinds of game studios, including like Epic. Like people get, it's a good bootcamp, right? And finally, the cybersecurity one, always in demand. Cybersecurity professionals are always in demand. One of the points I want to make is, I mean, so Lisa asked, which would be the best one for the job market? You're really going to, like, a lot of that depends on your interests, the amount of time that you have available to devote to study. You're really going to want to talk to one of our admissions personnel to get like the perfect answer. The fact is, we've had people get hired from every single one of these boot camps. Okay. So there's no 100% answer for that, but it is worth discussing. Everybody's like interests and availability for time and that sort of thing is different. So, in a little bit here, I'll give you a way to get a hold of one of our admissions personnel. Lisa, it's a good question. Another point I want to make here is that we have more certification programs than any other coding boot camp on earth, but it's how we deliver these boot camps we worked really hard on. They're self-paced, but also instructor supported. They're flexible. You set your own study schedule and you can enroll any day of the year. We have really well-rounded content, very in-depth. Thank you, Ryan. Appreciate it. Ryan said a nice thing about the way I teach, and I sincerely appreciate that. I was horrible at the beginning, so thank you. And also asked, which ones do I teach? You will, for better or worse, get instruction from me on every single one of these boot camps. Some people like that, some people don't. I'm a bit of a nerd, but what are you going to do? So yeah, the answer is on all of them at various points, right? So again, our content's really well-rounded. It's really in-depth. The boot camps are very affordable. Every single program on here includes job placement training and job placement assistance. But most importantly, they're all designed for absolute beginners. No prior technology, knowledge, or experience is required. You don't have to be a nerd. You have to listen to my stupid jokes in the curriculum, but what are you going to do? We consistently land on every major best coding bootcamp list out there, which we're very proud of. Our review rating, our average review rating across all of the major bootcamp review sites is 4.8 out of 5 stars. We've worked really hard on that, and that's based on student and graduate feedback. The people that are best in a position to tell others how they feel about our program have ranked us very highly. So, R. Anderson says, do you have access to the complete working Pong game? Let me grab that link for you. Hold on a second. I'm going to drop that into the chat again. There you go. Some of you may want to work in tech. Some of you might not. I'm just going to give a couple of reasons why you might consider working in technology. Generally, it has a really good work-life balance. I've been working in tech for many decades, and I've never had a job where you have to work more than 40 hours a week for any sustained period of time at all. That's kind of nice. Lots of remote work positions are available in technology. I've worked remote for the last 7 years. Absolutely love it. Okay. It's a really creative industry, and it's one where you can take a lot of personal pride in your work. You're solving difficult problems and you're helping people a lot. Okay. It's also a stable industry that pays really well. And if you apply yourself to it and keep on learning, you get regular increases in pay. And the pay in the technology industry is far above the national average. And you don't have to get a college degree to work in tech, which is cool. That said, there are barriers to doing a coding boot camp, fully acknowledged. One of them is money. It costs thousands of dollars to do a boot camp, right? Now, at the Tech Academy, we have multiple financing options to try to help everybody, including a big upfront discount, a monthly payment option for people that have no credit or bad credit. In fact, there's an option for everybody in all the financial situations. Most importantly, I firmly believe that getting through one of our boot camps is an investment in yourself. You're giving yourself a set of skills that are going to continue to be valuable for decades into the future. Okay. Another barrier is the time. There's a lot to get through in a boot camp, right? So some boot camp providers try to solve this by training all their students in what are called cohorts. Everyone starts on the same day and goes through the material at the exact same pace. I cannot tell you how much I disagree with that philosophy. I don't learn at the same pace as other people. Some things I learn really fast. Others, I'm telling you, it takes me a little while to get through. I can't tell you how many times when I was in high school, I was frustrated as all get out because either I was super bored because I figured something out fast, or more commonly, let's be honest, I didn't grasp it that quickly, and we just moved on. Everybody moved on. I'm like, well, hold on. I didn't quite, and they would never come back to it. I don't agree with that philosophy, right? And sometimes boot camps make you come in person. Our programs are fully online. They're self-paced, so you don't have to worry about getting left behind. You choose your own study schedule, so you can study part-time, and you can study concurrently to holding down a job, which is great. But the last thing I want to cover is this, in terms of a barrier to getting through boot camp. You do need to have at least some technical interest or ability. Well, y'all showed up for a free coding class on a Friday night. There's probably some interest there. It's the ability point I want to just make a statement on. If at any point in the past, when you were studying technology, coding, some sort of tutorial, a book, or whatever, if you ever for a moment felt like you weren't smart enough, or somehow that this subject was beyond you, I assure you, it's not you, it's the material. Many technology education materials are actually too hard to get through. And that's because a lot of educators, I've done it before in the past, so I understand it. A lot of technology trainers assume too much prior knowledge on the part of the student. With our programs, we've cracked that. You don't have to be a nerd. There's no technology background needed to enroll for you to get through it. So I have a question for you, or a few of them really. Are you working a dead-end job? One where there's a pay ceiling that you disagree with, right? Where you have to spend decades in the position to get up to really, really good earning potential. Maybe you're even unemployed. Maybe you want to work from home, or you want to have more time with your loved ones. The question is it time for a career change? Only you can answer that. But if it is, well, the Tech Academy is the solution. We're career change experts. That orange bridge there, we chose that specifically because we're trying to create a route into technology for everyone. At this point, we have well over a decade of experience breaking people into tech. Most of our graduates make $30 an hour on average in their first job. That's $60,000 a year, by the way. We've got over 1,000 graduates working in tech. In fact, it's rapidly approaching double that. And we've gotten them hired everywhere, right? Sam, I'll get your question in just a second, right? Or you can even type it into chat. We have people working small businesses, medium-sized, big companies like Nike and Epic Games, Disney, Uber, Facebook, right? And as a reminder, we have open enrollment. You can start anytime. So I encourage you to, start now. Now, let me show you how to do that. Gracie, can you drop this link into chat? And then Sam, if you would drop your question into chat, I'd love to see that. It'll only be shown to me and Gracie. So this link that Gracie just dropped into chat, it's just a simple form to find out more about the company. And I just want to assure you, by the way, it's not a spammy kind of thing. It really is kind of cool. You fill in a couple pieces of data, and after that, there's a form, a series of steps that tell you. Oh, thank you. Evan says Maria helped me. She's one of our admissions personnel. She's great. The process is very pleasant. I appreciate that because we worked really hard for that. All we're trying to do, frankly, is give you so much information about who we are and how we work. Open up all like a transparent view that when you're done with it, you know exactly whether or not it's the right program for you. We learned a long time ago, you just want to be completely transparent. So when you go to this link and fill out that form, there's a series of steps that will tell you everything about the program. Oh, Sam, I'm sorry for that. Is there, well, give me a question, Sam. I see that. Give me a question if there's a question in there, okay? Matthew, no, I'm not sure who they are. We're not associated with them. And I'm answering a couple questions here, giving some time for anybody who wants to click on that link to have a chance to, and then we're going to move on. We're getting your free gift in a moment here, so just stick around. Oh, I appreciate that. He said, thank you for your service. Thank you. I'm very proud of that. Thank you, Matthew. Appreciate it. All right. So I want to mention one other thing. It's kind of cool. Since our graduates really love us, referrals have been one of the top enrollment sources for us over the years. And so a long time ago, we put in place a commission payment of 5% for any enrollments that came from referrals. But that's not just for our graduates. That's there for you. Okay. Oh, Sam, that's a fair question. No, it isn't just for that. The primary reason we put these on is because we find that a lot of people have never had a chance to actually just write some code and have a chance to actually interact with someone who's an experienced programmer just to find out whether or not they even like it. And I'll be quite frank, having done hundreds and hundreds of these free coding classes, I found out something really wild. When you're writing these initial relatively straightforward programs, there's almost always going to be a point where the program just doesn't do what you thought it was supposed to do. And it can be very frustrating. I know it's frustrating to me, and I've been doing this for decades. Part of the reason we provide these free coding classes like this, where they're kind of raw and organic, and I come up with different examples each time of how we're going to build the functions and all that kind of stuff, is I want people to experience, even for a simple program, the fact that sometimes it can be stressful and frustrating because the code isn't working the right way. And if you get to the end of it and you find, man, that is 100% not for me, that's a valuable thing to find out. But if on the other hand, you get through that and you're like, huh, well, it sure felt good when it finally ran. It was worth the frustration. And I kind of like the way these guys teach. Well, then, yeah, absolutely. We'd love you to find out more about our program. But that's one of the main reasons we do it, is like, I want more people in tech. But to really paint a picture of what it's like to be a software programmer, you've got to have people experience a little bit of that. Like, it does not always go the way you think it's going to go when you're writing a program. In fact, it rarely does. But that persistence to push through and go, okay, I know there's something in here I'm missing. Let me look through it line by line. Let me walk away for a minute and then come back to it. And when you finally get it running correctly, it's an amazing feeling. But it isn't for everyone. It isn't for everyone. Okay. Lisa asked about average cost. I mean, anywhere from like, there's some programs that are $59.80 and some that are up to like 12. I don't know what the average would be because we've got 12 boot camps. Yeah, you'd have to talk to admissions personnel. And really, it's just like, what's the right one for you is the more important thing, Any one of the programs will prepare you to be a well-rounded developer, but what's the focus? Which of the focuses do you want? Okay. All right, good. So let's move on. And I just want to tell you, I'll go real quick here. We have 7 different publications we've written, 3 Learn Coding Basics books, right? a coding book for kids and young adults, a technology basics dictionary, a project management handbook, a book called You Are Not Stupid, Computers and Technology Simplified, which is phenomenal. But here's your free gift. It is our Introduction to JavaScript book. It's really, really good. It's recently revised. I think you'll absolutely love it. It goes into much more depth than we're able to do in one of these hour-and-a-half long classes. Okay. And we just want people to avail themselves of this so that, again, it's one more step in figuring out, is this for me? How is this technology? Am I really going to enjoy this? You can just read through it. It's full of drill after drill after drill, exercise after exercise after exercise of actual coding, so you can find out whether or not you like this stuff. Okay. All you have to do is grab the email address that Gracie just dropped into chat, books@learncodinganywhere.com. Send us an email saying, hey, Erik said I could have my free JavaScript book. Please give us your full mailing address. Otherwise, we can't send it to you. Okay. Also, if you want to drop in any other questions for me, you can drop them into the email there. And if you have any people you want to refer, we keep track of that. And if they sign up, we'll cut you a commission. Okay. Grab another sip of water real quick. I mentioned that we're going to tell you about all of our links. Gracie's going to drop this link into chat for our link tree. If you're not familiar with Linktree, it's just a single web page that collects all of your links for you or your company, right? So on there, you're going to find links to our free educational YouTube video playlist. It's quite good. There's hundreds or maybe even thousands of videos on there now. And this video will be there, like I say, within about a day. There's links on there to our books, our dictionary, our upcoming meetups, our social media accounts. So please follow us on social media, and please come to more of these free classes. Thank you so much for attending. In particular, I really like the interaction in chat today, all the questions that got asked. That's awesome. Okay. Let me go back through and see if there's anything else. Okay. Oh, Sam, I do want to answer that a bit more. Okay. I live in Louisiana, not Texas. Texas we were just over there though, and it was nice, although it rained a lot. So another answer to Sam here asking about this class and the Pong game and everything. If we were to try to actually build out the entire Pong game, there's two things that would happen. Because I've tried to do more extensive programs on these free classes. One is it would take about 5 or 6 hours, not realistically, not exaggerating, take at least 5 or 6 hours to build that out. Frankly, probably even longer. Two, the value of the learning, if you were brand new to computer programming, the value would be really, really low, because it would be like drinking from a fire hose. I would have to teach so many concepts to fully flesh out that Pong game that it would you'd want to go to sleep. One of the things we've learned over the years, the hard way, we've made mistakes over the years, right? And one of the things that I have to caution myself to do is not to just shove so much information down the student's throat, because they get so enthusiastic about this stuff. I love teaching it so much. And I've learned, especially right at the beginning of someone's journey, to give them tiny, simple fundamentals and make sure they understand those fundamentals super strongly, because that's their foundation for all of the other complexity you can lay on top of it, right? But we also like to provide people with the full code for the games here, so they can explore through them, tweak them if they want to, learn even more. So I hope that helps. Anyway, I think that's it. Yeah, Matthew, get the mailing address to us so we can send you your free book. And we've gone 15 minutes over, and if I don't get out of here and watch Outlander, which just came out tonight with my wife, I might not live through the night. So if you haven't watched Outlander, I don't even know what to say to you. It's one of the best shows ever made. It's fantastic. So, all right, cool, Matthew. Thank you so much. Everybody have a great evening. Appreciate it. Glad you were here, and we'll see you at the next class.